Hello, this is my subject knowledge assignment for my teaching course, and what I needed to do was adapt or create a teaching resource for the purpose of improving pupils' learning in your subject. So I'm a science student teacher, so I chose a topic that my year 7 class were currently learning, and I chose to make a resource based on that, and then to help them with their particular learning through the subject. So the subject that I chose was separating mixtures and distillation. So I chose my year 7 class because I get on with them quite well, and they're very keen to learn, and they're really good at identifying misconceptions and working through different types of work. So the topic was distillation. However, this was the end of the separating mixtures whole topic that we'd done. So before this, we'd gone through pure and impure mixtures, elements, compounds, melting points, and that we'd gone through chromatography, filtration, evaporation, and magnetism. And then what I wanted the learning outcome to be at the end of this lesson was that I wanted them to be able to separate a mixture depending on physical properties. So I was going to give them physical properties, and I wanted them to be able to pick a type of separation technique based on this. So, Key Stage 3 subject knowledge and the sequence of learning. So, according to the Department of Education, the subject knowledge that the Key Stage 3 learners should have is the concept of pure substances, mixtures, including dissolving, so this includes solutions, solvents and solutes, diffusion in terms of the particle model, simple techniques for separating mixtures, which is filtration, evaporation, distillation and chromatography, and then identification of pure substances. So before this distillation lesson, I'd gone through every single one of these. So as to sequence, we'd gone through pure and impure substances, mixtures, or we went through all of dissolving solute solutions, then diffusion in the particle model we talked about quite before this, because the particle model was a separate topic to separation techniques. As I've said before, we'd been through filtration, evaporation and chromatography. So what I wanted to do during the lesson that I was teaching was the sequence I was going to base it off was how evaporation can be used to separate substances, know that different liquids have different boiling points and melting points, and explain how distillation works, and then identify the correct method for separating different types of mixtures. So, common misconceptions. So, during this lesson, I identified quite a lot of misconceptions. However, I also went further onto the Royal Society of Chemistry Education and identified more misconceptions before going into the lesson, so that I knew exactly what some of my students would ask. So firstly, some students believed that all liquids had boiled at 100 degrees and froze at 0 degrees. So obviously we know that water boils and freezes at these temperatures. However, not all liquids do this. Some students didn't understand the concept of how heat is not energy. That heat is energy, and they believed that heat wasn't energy. So when we heated up objects, or when we heat up substances such as liquids, they gain energy, and when you cool them down, they lose energy. evaporating and boiling are the same thing. So people may not, students didn't know that evaporating and boiling are different processes. Water flows through the condenser and not around it, so this is very specific towards the lesson's topic. So this is talking about the Liebig condenser and how water flows around the Liebig condenser and not actually through the condenser. So what flows through the condenser is your distillate as that cools down, and then obviously not water doesn't flow through it, and that all mixtures are separated using only one separation technique. This is obviously not correct because we've been through quite a lot during different lessons of how to separate different mixtures such as sand and water, and then obviously we can't separate certain things using the same method. So this helped me move on to what I wanted to base my resource off. So firstly, I wanted to look at diagrams in science, because as being a science teacher, you know that diagrams are really, really important towards the learning of students. In the first sentence there, it says, in science learning, diagrams effectively help students learn the principles behind phenomena. So we find this is true because diagrams help visually give students an idea of what they're looking at and what they're seeing, so that diagrams are an easy way to kind of visualize exactly what's happening. From Ainsworth, Prane and Tytler, making visualizations is integral to scientific education. Scientists do not use words only, but rely on diagrams, graphs, videos to make discoveries, explain findings, and excite students' interests. So, as I was saying, science teachers can use like a plethora of visual stimuli to excite students' interests. So we use diagrams, graphs, videos. However, I'm just talking here about using diagrams to explain the process of, in this case, distillation. And then lastly there, I thought this was a nice little thing to include, because it said results from a study conducted on students show that pupils given diagrams perform significantly better on post-tests than students given text. Diagrams students also generated significantly more self-explanations than text students. Okay, so this just helps you paint a picture that students that are given diagrams to help them visualize what they've seen perform significantly better on post tests to what they've been given. So I find that diagrams are easier for students to understand. They're easier for them to learn from than just a big massive wall of text. So this is why I chose my learning resource, as I thought that using a diagram would be a really easy way to gain whether they knew exactly what they've learned, and then they could actually put it to the test, name different parts of apparatus, and then when it's all a whole, they can know what the process looks like. So here is my resource. So as you can see, I've got two things on the screen here. So on the left hand side, I have a diagram on distillation, and on the right hand side, I have a progress check describing evaporation and distillation. So firstly, I want to talk about the left hand side, so the apparatus and the diagram. So I chose a nice simple apparatus and a nice simple diagram. It's not too confusing. It only contains the really needed information. And then I put down the following key words. So these include heat, beaker, solution, distillate. These are all words that they need to know for tests and 4 assessments that will come later on. So I made sure to include definite keywords from the specification so that they knew what they'd have to write in the future. So obviously this diagram here helps paint a picture of how distillation works. You need obviously your thermometer, your Liebig condenser, your beaker, things like this. This resource also, in my opinion, helps address the misconception that water flows through the condenser and not around it. As you can see, the arrows going in and out of the condenser, which is the oblong cylindrical shape on the diagram. You can see that the arrow going into the outside, not in the pipe, is where the water goes in and where the water goes out. So that really thoroughly kind of addresses that misconception straight away, so students can't get mixed up. Then on the right hand side I have a progress check, which was to do with describing evaporation and distillation. So this was just a simple gap fill. So all I needed them to do was complete the following paragraph about evaporation and distillation. So they had keywords at the bottom of their sheet, and all they needed to do was put the keywords in the correct order. So, for example, when particles leave a liquid and turn into a gas, this is called evaporation. Exactly. So that's all they needed to do, and I found that students performed quite well to do with both of these tasks. However, I'd say that for the first task on the left hand side, the performance was best. How was the resource adapted for students? So in the class that I teach in year 7, 7I, the class I gave my resource to has very minimal SEN needs. So I made the resource with the mind that the class should be challenged. However, each one of them should get to each answer by themselves. So I wanted to make sure that they all worked independently through the sheet. So I made sure everyone was quiet and we had a nice calm atmosphere so that everyone could work by themselves, so that they could get to the answers by themselves. Because when it comes to a test and an assessment scenario, they won't be able to ask anyone for help. So I wanted to make sure that everyone was doing all the work by themselves. So for reflections and feedback, so all the students in the class that day were able to fill out the missing labels for the pieces of equipment. A small number of them struggled with the idea of the condenser. However, once I made another explanation and through demonstration and other things, this was quickly changed. So their idea of the fact that the condenser and the water flowed through it rather than around it quickly changed, so that everyone by the end of the lesson knew exactly what they had to, where the water went through the condenser. For feedback from the observing teacher was that the resource you used was great, and it really helped students identify different parts of the apparatus and how distillation works, and that SEN needs for the class were met. As I said before, SEN needs are very low in this class. However, for the ones that there are is hearing impairments, which I was able to combat by every time in the class all the students who have hearing impairments are closer towards the board and closer to me, so that I can be as loud as possible for them, so that they can all understand what I'm saying. And then adaptations for the future. Firstly, I think differentiation is key. So in the future, having multiple sets of the worksheet for each different level of ability would be great, just so that people can understand that if someone doesn't get one thing, they can do something else rather than being stuck on one thing for the whole lesson. And then lastly, I would want to have put an extension activity underneath what the students must complete. So is something that will be added. So as some students did get through all the work set very quickly, so I want to add extension tasks such as questions on distillation so that they can get on with that and maybe not disrupt the class. Thank you.